to you today about a very new project that we just started at Eclipse called the Flux project. I'm actually going to spend a lot of my time just jumping right in and doing demos, and I'll kind of explain how it works afterwards. So, to give you a bit of motivation, so this is Eclipse, right? This is the latest, Luna RC, whatever, the latest Eclipse platform in Java tools. So this is, you're all familiar with it. It's the culmination of 10, 15 years of development on tooling, and it's got a lot of capabilities to it. Some of the key capabilities that Eclipse has as a tool platform is it's got this massive ecosystem of tools, right? There's language tooling for Java, for C, for PHP, for Ruby, for whatever language you want to do. There's probably tools for it. There's plugins for deployment to whatever you want to deploy to. Whatever your build technology is, there's probably plugins for that. So it's got this huge ecosystem of tools that are available to you. It works well with other local tools. So if you're using an IDE in conjunction with command line tools or other tools on your desktop, Eclipse integrates really well with your existing tools that you're able with. And another one of its key strengths is that it's cross-platform, right? So at least for the platforms that developers used 10 years ago, Eclipse is available on all of those, right? So it's
okay, so that's Eclipse. So you're all familiar with that. So, but what about this other tooling platform that has just recently emerged? So, desktop tools have been around for a long time, but the notion of this is the Chrome browser is actually a tooling platform, and more generally, the cloud. I used to hate that term, the cloud, but the more I think about it, in Orion we always said browser-based tools or web-based tools, but it's actually a lot more than the web and about HTTP and HTML. It's actually this notion that you have this opaque environment where tools can be running, and you don't really care what that environment looks like, right? It's in the cloud. You don't care how the storage works. You don't care how the operating system is managed. You just care about these devices around the outside, your desktop, your tablet, whatever that you're using to interact with the tools. So it really separates the environment in which the tools are running from the environment that's interfacing to the tools. So that separation is really interesting. So, what are some of the key capabilities of the cloud as a tooling platform, just generically? So, Eclipse is cross-platform for all the traditional desktop environments, but it doesn't run in mobile, on your tablet computer. It doesn't run in every single server environment, so it's not completely ubiquitous for the modern computing environment as far as cross-platform. So cloud certainly has an advantage there. Another aspect, of course, is this extreme scalability, right? The key reason a lot of people move to the cloud is that they have this environment where they can, let's say they have 1,000 developers. If they're not using their tools, they don't need any compute resources. If they're suddenly doing large amounts of builds or tests, they can rapidly scale up that environment to suit the demands of the tools at any given moment. So that kind of flexibility, both upwards and downwards, is extremely valuable. It saves you a lot of costs when you don't need it, and it gives you immense compute resources when you really do need it. So another aspect, and this is something that actually I added when I was thinking about it on Monday. I was privileged to get a tour of Airbus, and it was really eye-opening to see what the tooling environment looks like at Airbus. It's a very, compared to your typical software developer, it's a very highly controlled, highly tested, highly very carefully configured sort of tooling environment. So that's one thing that the cloud can do really well. I'm actually just going to give you a quick demo of this, which isn't actually a super exciting demo, but I think it proves the point. So, just going to make sure I can SSH. No, I can't. So apparently your town doesn't like port 22. I haven't been able to SSH. Yeah, so I'm supposed to be on this. It's not a big deal if this doesn't work, because everything else I've got running, I'm on that. One last try. No, okay, not a big deal. So I'm just going to go back here. So what I was going to show is, this is a very unexciting page. You don't need to be able to see it all. This is the about dialog for the Orion tools, which are, the Orion is a project that builds browser-based tools, and they have Orion Eclipse Org is the server that they use for development of Orion. So all the plugins used to build Orion are on orion.eclipse.org. And what you're seeing here is the about page, where I see the exact lineup of every single set of plugins that are installed in that environment. So I know exactly what plugins Orion developers are using today. And I can see at the top that it's using yesterday's build, and we usually update every day. So I was going to run, there's a script that we run usually every morning to upgrade our tool environment, and it takes about 5 seconds to run, which is one of the really cool aspects of it. And in 5 seconds, that team of 30 people instantly gets the new build. They don't even have to think about it in the morning. They come in, they open their browser, their new tools are there. And Orion Hub, which is our demo server, which has 25,000 users, exact same 5 seconds. So we can run the script, 5 seconds, 25,000 people have a new IDE, like a new set of tools. And if you think about the cost of maintaining your own development tools and all the aggregate cost of all of your developers having to manage their tools, there's a huge saving there as well. So yeah, so it's a highly configurable, highly controllable if you want. I know developers are nervous about this idea that their tooling environment can be totally locked down, but there are some people in some environments where they really want to be able to do that, completely, precisely control the set of tools you're using. And you can also see, I was going to quickly show you in our deploy logs, I can go back to, February of last year and tell you exactly what set of plugins everyone was using that day as well, which is really valuable in some situations. Okay, so that gives you an idea of some of the promise of cloud as a tooling environment. But what about the current state of cloud tools? So I'm just going to give you a very quick demo of what is possible, and maybe some of you have seen this before. So I'm going to show you Orion, which is an Eclipse project that is building browser-based tools. Now I have to log in. I forgot I'm on localhost. It's not my hosted environment. Okay, so I have, and let me, sorry. Let's try that again. Okay, so this is Orion. It's a browser-based editor. It has, this, I'm on a JavaScript file that is, 7,000 lines. It scales really well. Like, the performance on this is just as good as the desktop for your core editing tasks. It has, it has Git integration. It has search. It has a lot of the basic capabilities you need for your day-to-day development. But I'm going to go in here. No, I don't. I'm sorry, I switched. Let me try it. Here. Okay, well, I was just gonna, all I was gonna do is open a Java file to show you that what Orion can do with Java is just syntax highlighting and nothing else. You don't get any kind of validation features. So this is, this kind of tool, these kind of tools show you, kind of give you a glimpse of what is possible, that there really aren't any limitations of the environment in the ability to build tools. But the current set of tools that are available are fairly limited. So there's these big gaps. And it's going to take years, right? It took, there's been 10, 15 years of people building plugins for Eclipse. There's a huge environment of tools there that are at your fingertips as a developer. And if you move to this new cloud environment, those tools aren't there. Okay, so you're faced with this difficult choice as a developer. If you believe in this promise of cloud environments and the power they can bring, and you're really interested to try it, you have to make a choice. You have to either stay with your existing desktop tools and wait, maybe a few years for the technology to mature, or you take this leap into a cloud environment where you get, this immediate promise of you don't have to even think about, installing or upgrading Eclipse anymore. Like, that's really liberating. You don't have to worry about, managing your tools. You can develop anywhere. I can grab any laptop in this room and my whole tooling environment is set up. So it's great, but I've left behind these other tools that some of them I really need and are not available. So the question, many of us who are working on cloud tools have been posing to ourselves is there any way that we could have both? So, and that's something that we've been working on, and I'm going to give you a quick demo of that. Let's close that. So I'm going to go back to Eclipse. I have this Java class here, and I'm going to, actually I'm already connected. I did not set up very well. There's this new menu here called Flux, and it says connect. So what this is doing is it is connecting my Eclipse desktop environment to the cloud. So it is making the content in my workspace available to cloud computing environments, and it is making the services, the tooling services available in Eclipse, exposing those as services to be available in the cloud. So now if I go back in the browser, and I again have an Orion editor. It has only Java syntax highlighting, not very useful. But now if I start to type, I get immediate syntax validation. So I type the letter C and it says missing semicolon, right? So the standard Java error. And what's really exciting to me is actually the speed of this. So like the second I type, boom, the error is there. So it's really fast. So I'm gonna write some Java here. I'm a dragon, so I'm gonna raise a gate and I'm gonna breathe fire. So this method, what's wrong with this? This method does not exist, so let's create it. So I'm going to do the traditional navigation feature, hit F3, and jump into this interface that I have here, and I've got a method that I'm going to define. Of course, I support Java 8 as well, so I have a default implementation of this method. I'm going to go back. Oh, and I think I typed it wrong. Yeah. There we go. And as soon as I typed it, I'm happy. So we've got syntax highlighting. I think I might have moved too fast to show you that there was also content assist. The navigation features, I can select a method reference and jump to the declaration of that. I can even jump into the source code of Java lang string. Don't look, it's proprietary. So, oops, shouldn't have closed it. So I've actually got quite a lot of capabilities here. I even have the ability to do rename in file. So I can hit F4, I think it is on this file, and go burn building, and I can rename in file, and it updates all references to the method in the file. That gives me an error because, right. Okay, let's move it back. For burn. Oh, shoot. Burn, no. Now I ruined it. What have I done? Here's the demo effect for you. Oh, I have messed that up, haven't I? There we go. Luckily, undo still worked. Breathe fire. All right, burn castle. Okay. So, and the way it's doing this is, so I have an Orion editor here, and I actually still have this Eclipse in the background. So I can go, if I put these side by side, I can see, okay, I got a Java, I've got Orion, and when I type here, the typing is appearing there. So this is actually working with a live synchronization of the editor buffer across these two environments. So I can actually, not that this by itself is an exciting feature, that I can actually go to either of these editors and type, but it shows you what's happening there is that it's actually, the browser-based tooling is actually plugging directly into the editor buffer and the live compilation unit model that the Java tooling exposes in Eclipse. So that's pretty neat. And one thing I find kind of funny here is when I type and I introduce an error, the error actually appears in the cloud editor much faster than it appears in Eclipse. So if I start typing error immediately, and the error in Eclipse actually takes another half second to appear. So it's actually, it demonstrates that there isn't really a performance cost to having this disconnected environment by itself. It can actually be extremely fast. So back to my presentation. Okay, so the way that demo was working was using the technology in a new project called Flux. So this is a new Eclipse project that was just created in the past few months. It is, it's past the proposal phase. It's now a real Eclipse project. It has source code available in the GitHub repository. Eclipse projects can be hosted in GitHub now, and this is one example of our project that does that. So the source is all available. And the whole point of this project is to define an architecture and technology to bridge this gap between desktop and browser. And I wouldn't claim that we have a final answer or that we've come up with the ultimate technology to do that, but that is the space we're exploring, and this is the prototype we have available so far to make that connection. So just to give you a quick overview of what the architecture looks like. So this is the architecture of the demo you just saw. So there is this, in the middle, there is this message bus. If you think of like traditional message broker technology, it's the same idea. You could have like RabbitMQ or whatever in there. And it is communicating with asynchronous messages to these different tools that are available. So in this demo that I gave, we have an Eclipse IDE with JDG, Java tools in it, and the workspace. Both of those are exposing services. They're publishing, I have this service available, does anyone want it? Asynchronously, and asynchronous message bus can then use that to coordinate with the browser editor. When the browser editor opens, it says, hey, I would like a content assist service for Java. Is there one available? And the broker mediates that and hooks up those services together. What is really interesting about this environment is the flexibility of it. So it enables this model where you have Eclipse desktop tools exposing services. You can have tools running in the cloud. But you can imagine how it evolves in the future quite easily. So, down the road, you might actually have an environment where you've got different types of computing tooling services that are available all over the place, right? You can have, maybe you've got something running in Amazon that's doing really complex, syntax, static analysis, for example. Or you might have another tool running on some other cloud up in the right corner here, which is doing continuous backup. So it's taking everything I type asynchronously, saving that away in some other storage offsite in case my laptop explodes. I've got my content backed up all the time. So you can imagine all kinds of different services growing up around this message bus and can be deployed in lots of different ways. And one thing to me, so I've been working purely in the cloud tooling world for the past year or so, and what I find very exciting about this architecture is even, let's say, 10 years from now, we're all, who knows what has been invented to replace whatever our devices are today. I could imagine that this exact same architecture works in a world where the Eclipse desktop isn't there. Like maybe even you're only using it, like maybe you're on the road and you don't need the desktop, or you're in your car or on a train, or you're in some environment where you don't need the desktop. This exact same architecture still works really well. And we've actually convinced ourselves of this. I've been helping this team within IBM that's building quite a large cloud tooling project. And this is the exact architecture that we ended up with after a lot of trial and error, was this world where you have decoupled services running possibly on different hosts. They're certainly on different compute nodes. And you want to have really loose coupling between these, because otherwise you have a very brittle system. So, in the early days of this environment, if one tool went down at the wrong time and didn't receive an event it needed from some other service, the whole system was screwed and you kind of had to bring everything down and bring it back up again. So it was very brittle. With this asynchronous message environment, it's much more resilient. So you can have a service go away, you can have new services come in, and the message bus can queue messages for delivery if the node who wants to receive it isn't available. So there's a lot of redundancy built into the system. It's very flexible, very powerful. If you want to add a new service into the system, it can just publish the services it provides and consume the services it needs. None of the other services even know about it, right? So it's a really powerful architecture purely in the cloud world. But what's really cool is it also, going back to the previous slide, lets you integrate all these desktop tools as well. So you can use it with, as soon as you've got that Eclipse Workspace synchronization, you could easily use all of your Eclipse plugins some of the time, and then other times you're working in a cloud environment and you can use any kind of combination of those tools. So just to give you a quick rundown of the main work areas of the project right now. The first area is this core messaging system, and the Flux has this notion of a repository, which is providing content and technology for synchronizing repositories. So in this demo, we had two repositories. We had one based in the browser that was actually in local storage, and another one based in the Eclipse Workspace, and it was managing synchronization between those content repositories, and then the message bus for connecting up services. So the two key languages we're working on, we really believe that if you focus on one language, you end up building a technology stack that's really highly suited to that language. So this is something in the early days of the Eclipse platform, Java was the main use case, and a lot of the technologies in the generic platform inherited some Java-isms, like the notion of incremental compilation was really big, and that didn't necessarily apply to other languages. So something we're consciously doing in Flux is to develop tools for two quite different languages at the same time. So we want to work on Java tools that are connected to this environment and are available in browser-based editors, but also JavaScript tools. So the Orion has JavaScript tools that are purely browser-based, but there are other technologies where you're running JavaScript validation on a server, and you can expose that as a service and make that available even in Eclipse desktop, right? So you can flip that around and say, syntax validation for JavaScript is implemented in the cloud, but my editor is in the desktop, and I can reverse it and connect it up that way. So those two language areas are major work areas. And then the fourth area, which we actually really haven't started on yet, is deployment and execution. So you have written this application. How do you get that deployed, and how do you manage that life cycle around round trip of I make a change, I want to deploy it, debug it, make a change again, deploy again. So you want to be able to manage that kind of interaction. And if you're using, say, a cloud platform for your runtime, it's a very natural fit to expose services in the cloud to help you manage that. So that's the fourth work area that we've been talking about, but we haven't really dug into yet. And then finally, the project is very new. We're certainly open to other people joining who have other ideas about what they want to do with this. So insert your work area here if you're interested in tools for a particular language, particular build technology, whatever, particular past deployment technology. We're really interested in you trying this out and working with us in defining what this looks like. So just some quick references. So this presentation is available in my GitHub repository. So if you go to that, you can click these links and find everything else that way. There's also a Flux wiki page on wiki.eclipse.org, which has links to some demos that have been done, links to the source code, some other information on the project. And finally, the Flux source code itself, which is available on GitHub. So that's actually it for my presentation. I think I went through that pretty quickly, but does anyone have any questions? Okay, I think I'm actually out of time because there's going to be another talk starting, so thank you very much.